Welcome back, everybody. All right, this is OSPF. We've done RIP, well, we've done static, defaults, we've done RIP, and now we did EdgeRP, and now we're going to do OSPF. Now, OSPF is a link state routing protocol. Unlike RIP, which is distance vector, right, and EdgeRP, which is an advanced distance vector, is you'll have the limitations on hop counts. OSPF pretty much has no limitations. OSPF is based on areas, and it has 4.2 billion areas that you can create. So that's very scalable, right? Not as scalable, and I will do this as well, not as scalable as ISIS. It's twin brother, okay? It is a link state routing protocol that was configured originally just before OSPF, but they never took off. Well, it never took off from the mainstream. Only big ISPs and data centers use that. Telecommunications use ISIS. All right, so we need to get familiar with that. So next routing protocol after this one is going to be ISIS, at least the basics, and then we'll keep doing more videos, more advanced, try and keep them short as possible. But with OSPF, again, is based on areas. For now, we're going to do a single area OSPF. That means all the routers are going to be in the same area. They talk to each other. They create something known as a link state advertisement. There's different numbers of them, LSAs, LSA1s, right? Intra area, intra, okay? So the IPs are already there. So this is the 10.1.1.4, right? So this is 5 and 6. This is 10.1.1.8. This is 9 and 10. This is 10.1.1.12. This is 13 and 14. And you have loopbacks. It's got all ones, 1.1.1.1, 2.2.2.2.2, 2.2.2.2.3. All right, that's what they are. So we got the IP address over there. I'm not going to bore you with that. So let's go straight for it. All right, let's configure it. So we do router, OSPF, question mark, process ID number. Everybody uses one. Why? It doesn't matter, right? Really, for normal configurations. In more advanced configurations, like with using VRFs, you will use different process ID numbers specifically for different VRFs. Don't worry about it. But for right now, it's local. It's local to your router. It doesn't matter if router 1 has process ID 1, router 2 has process ID 2. You don't care. We always put 1 so we don't have to remember. If we have to go back into OSPF and fix anything, we know it's OSPF process 1. That's the only reason. That's laziness. Okay? That's the only reason. All right, so network. Network. All right, now here you do need to put the full networks, and we need to use wildcard masking. So you need to know wildcard masking. Okay, so we have two 10s here, right? We got the 10.1.1.4, and we have the 0003. That's your wildcard mask. It's going to be in area 0. That is a backbone area. Yeah, that's the first area that needs to come up. It's the backbone area. All right, I'm going to go up again. Goes down here, 4812. We got the 12 as well. Okay, and we also have that loopback. So we're going to do network, and then it's 1.1.1.1, 0.0.0.0, because it's a 32-bit mask, area 0. So those are, I put a little period in the front there. Sorry. All right, so those are our 3 networks right there. Let's copy that. All right. In the old days, if you were taking the test, you had to go back to privilege mode and do a copy run and start. IP protocols. Let's take a look at it. Let's move this all the way up. All right, again, don't worry about this. So here we got, let's hit space bar for more. All right, so we got our routing protocol, OSPF 1, process 1. All right, here's our router ID. It chose it automatically using the loopbacks. If you have loopbacks and IP addresses on your physical interface, your loopbacks will trump the IP addresses on the physical interface, okay? So it'll choose that, the highest loopback. If there is no loopback, it'll be the highest IP address on any physical interface. And here we're routing for these particular networks. The 10.1.1.4 and 10.1.1.12. Cool. And the default administrative distance is 110. So it's pretty cool. There's a normal area, right, that we're in. It's not stub. It's not so stubby. It's not so stubby area. Okay. Much later. So this one's good to go. Let's bring this back down. Router OSPF 1. Well, don't matter. I'll leave it there. Network, and we got 2 10s. We got the 4 and we got the 8. So we got 10.1.1.4, 0.0.0.0.3, area 0, network. And you see we built an adjacency. See it says neighbor 1, gigabit 0, loading full. 7 stages, right? Full will be the last stage. Network 10.1.1.8, 0003. Ah, there's that period at the beginning. 0.0.0.3. Area 0. Okay? And then lastly will be the loopback. So we're going to do network 2.2.2.2, 0000, area 0. All right, that's done. Let's take a look at that. Show IP protocols. All right, there you go. These are the networks you're routing for. Maximum path by default is 4. There's your router ID, which is your loopback, which is correcto. Okay, so you're good to go there. And then lastly, so we can do conft router OSPF 1 network. It's 10.1.1.8. All right, let's do that one first. 0.0.0. Come on. 0.0.0.3. Wake up. All right, network. Ah, it got me. Network. See, it doesn't matter process ID. You're still going to create your neighbor relationships. Okay. Network 10.1.1.12. 0.0.0.3. Area 0. And then we got the loopback. Network 3.3.3.3. 0.0.0.0. Area 0. DWR. Control Z. Let's do show IP protocols. Show IP. Oops. Control shift. I didn't do Control Shift 6. Not working. Control C. Control Pause Break. Doing everything in the world to break that. I didn't do no IP domain lookup. That's what happens. That's why I type those, because I can't break it. Control C doesn't let me. Can I do it in here like this? No, can't do it. All right, here we go. So what was I doing? Oh, it's verifying. Show IP protocols. Show IP protocols. All right, we got the 2.2.2.3, 10.1.1.8, 10.1.1.12. Cool. Let's take a look at the routing table. Let's bring it up. Only up to there. I can see the whole thing. Show IP route. All right. Now, if everything works, which it did, we're getting O's, right? We're learning about the 1.1.1.1. We're learning about the 2.2.2.2, and we're learning about the 10.1.1.4. Everything else is directly connected to us. Okay. So you can see here that the administrative distance is 110, and we have 2. Not a hop count. This is considered a cost. In RIP, you have hop counts. In EIGRP, you have metrics, which we'll get into all this. And OSPF is cost. So it evaluates. OSPF is full of math. It was the physicist who created OSPF. So there's tons of math. All right, shortest first path algorithm. Okay, it's very complex. It's a lot of weight on the CPU. Okay, it does a lot of processing to get things out there. It's very scalable, but you really need to design OSPF correctly, or it could become a burden, to be quite honest with you. That's why ISIS, that's why they're putting it now in the CCNA. They're mentioning it in the CCNA. In the CCNP, they mention it slightly. In the NRC, they're going to ask you questions. So you need to know ISIS. This is going to be a protocol of choice in the next iteration of this. All right, so there's OSPF. There's your routing table. It's working. So I am in router 3. Router 1 is right over here. Router 2 is right up there. So I'm going to ping 10.1.1.6. And I can. Obviously, I can ping 5. Right, and I can ping who's directly connected to me. And let's ping the loopbacks. Let's say 1.1.1.1, 1.1.1.1. And I can. So we have connectivity all the way around. It's not a big deal. Not a big deal. Another thing that you want to look at that's going to be interesting is they're going to be about elections. But when we get there, we'll do it. I'm just going to show you. Show IP, OSPF. All right, which interfaces are this? Show IP in brief. Just want to look at the interfaces over here. All right, let's look at the G00. Show IP, OSPF, interface G0/0. Now this is an important command. Okay, why? Because this tells you the network type that is broadcast. Okay, you have your router ID right here. All right, since it's Ethernet, it's showing you your designated router and your backup designated router. It should be inverse, really. This should be the designated router should always have the highest IP address. So this is kind of messed up. All right, and then you have your hellos and deads. This is very important. Hello packets is how, consider them keep alive. Every so often, that's like create neighbor relationships. They send out hellos. All right, so if it is a requirement that the hello and dead timers are identical from peer to peer. The two routers are connected to each other. Those two interfaces need to have identical hellos. If not, you're not going to communicate. That's one of the requirements in the 7 stages that you need to make sure that it needs to have that same timer. Okay, so when you go in here, that's what you look at. But we'll learn how to change the broadcast type. All right, and we'll do a DR, BDR type of election, topology, so you can look at the election process. But this is OSPF. And OSPF as well, all the things that we'll be looking into, show IP OSPF, so OSPF, neighbor. All right, you can do little neighbors right there. Now remember, all these, RIP, EIGRP, OSPF, these are IGPs, even ISIS. These are IGPs. So they're dependent on the topology, right? It follows their neighbors, all right? The word BGP, when we get into that, BGP does not. BGP can have a router here, router 1, router 2, and router 3, right? My head is router 2, right? So I can make a neighbor relationship between router 1 and router 3, and 2 doesn't need to know. Okay, you can do that with BGP. You can do it with BGP because BGP, you can consider it a control plane protocol or an application for network layer reachability. All right, that's what it's for. That's what it's for. Normally, you first configure an IGP, and then if you want to use BGP, then you use it. All right, so normally what you do in BGP is just peering, unless you really want to use it as a routing protocol. But BGP does have a full view of the network, where OSPF, EIGRP, RIP, okay, ISIS, they do. All right, so this is OSPF. We're all in the same area, single area. But if you have 4.2 billion areas, you know you're going to be doing multi-area OSPF. And then, but we got to learn a bunch of things before we get there, all right? Which is, we need to understand the types of LSAs that get created, because you have the backbone, which is area 0. Then you have area border routers or boundary routers, autonomous system border routers or boundary routers, right? So we'll create labs like that, straight to the point, so you can see how that works, okay? But this is it. It's pretty simple, right? Basic configuration is no big deal. As long as you know your wildcard masking, very important, okay? You can go on the networking doctors. I think there's somewhere here in this channel, and Success with Laz. But in the networking doctors, if you can't find it here, there is wildcard masking videos there as well, okay? Or you get the book on Amazon, the only IP book you'll ever need, and you'll get it. All right, but you need to know your wildcard masking and pay attention there. And you see that the process ID number is just local to a router. It means nothing. Okay, for now, it means nothing. All right, so that's pretty simple, OSPF. See you in the next one.